name is Brian Smith of XR Corporation. I'm a Senior Field Applications Engineer. And today I'm going to be telling you how you can use XR's digital power controller family to enable a very high density tight layout despite having to have external MOSFETs. External MOSFETs are required with the digital controller, but that does not mean that the layout is going to take up more space. As a matter of fact, the net growth in board space consumed is going to be zero, as long as you can do a dual-sided layout. The reason is, well, there's two reasons. One's technique, and one is pretty much a benefit of using digital control. The technique side of things is that the MOSFETs lie very nicely underneath the inductors on the back side of the board. You can almost be guaranteed there'll be space for the MOSFETs because underneath the inductors is a no man's land for routing and component placement because of electrical noise and magnetic noise. The MOSFETs are part of all that, and they exist very well there. And I'll go through what I've drawn here on the board to kind of explain positioning and how that works. The other reason, the benefit the digital control that enables the tight layout is a typical PWM controller, an analog controller, requires upwards of a dozen pieces of popcorn around it that you have to dimension to enable soft start, feedback, compensation, current limit. The list can go on and on depending on how many features you want to enable. In a part like the XRP7704, where there's 4 switch mode controllers, that's the equivalent to dozens of components that would, in a normal scenario, wrap around like a moat around the part that you would have to lay out, provide for vias, ICT test points, and it becomes a real challenge to even get the powertrain close to those components because you even want to keep them quiet so you spread them out. The digital controller needs none of that. So it allows for the control chip to fan out very tightly to the powertrain components. So you can very easily route to the switch node, the power ground, the gate drives, and it all lays out very well. So you can bring all the components in closer and actually get a smaller layout. As far as routing or layout suggestions to sort of decode what I've drawn on the board, our digital controller, being a 4-channel controller, is going to sit very central to the powertrain components. And here I have along the periphery 4 sets of switch mode inductors, and I've simplified this a bit. On the inductors boxed on one end in red are the switch nodes. This is the high dV/dt switch node that you want to keep away from your sensitive noise sources, and you want to keep small. Your sensitive noise components, and you want to keep small. What I've done here to the right is I've blown up the back side of the board underneath one of those inductor powertrains. And what you have here to kind of decode, in the red box is a switch node on top. On the red box here is a clone of the switch node on the bottom stitched together with vias. And in here is a dual MOSFET package. As you can see, the switch node very easily connects to the switch node of the package, and it's very easy to route planes for your input and output capacitors. So ultimately, you are placing the MOSFETs directly underneath the inductors where there's plenty of room. The entire powertrain can be brought in closer to the control chip to give you a net layout that's very high density. So in conclusion, the digital power controller, even with external MOSFETs, will give you a very tight layout. It'll give you all the benefits of digital power control, and you get all the benefits of being able to select your MOSFETs to scale to the power levels you need, and you get the efficiencies you want. Thank you very much.